Hello and welcome back in this new video of the series From Zero to Motoko. So let me show you what is planned for today. We'll start with a discussion about variables, the two different kinds of variable, which are let and var. And to illustrate that, we'll make a simple calculator as an example. Then we'll talk about modules. And modules are a really important concept of the language because modules are what allow you to utilize functions from other pieces of code, basically. And in Motoko, you have three ways to import modules: from the base library, from your own code, and from external code. And today I will explain how to import modules from the base library and from your own code. I will make another video later to explain how to import modules from external repository. Finally, we'll quickly see how to upgrade your code and your canister, what kind of problem upgrading can cause, and how you can fix that. So let's jump in. Alright, let's start simple. There are two main kinds of variables in Motoko: let and var. Starting with let, you can define a variable using the word let, as in this example, let x of type nat equals 0. Those variables are fixed, which means everywhere in your code x will always equal 0, or the original value you gave it. And if you try to reassign x to a new value, it will throw an error because x cannot be reassigned. This is what we call immutable data. Now let's see what we can do with the keyword var. So we can also define a variable with the same syntax. So var y of type nat equals 0 again. Originally y is equals to 0, but this time the value of y can be changed later in the code, and you can do that with the reassignment operator using this syntax. So y can be reassigned to 1, for example. You need to be careful because you cannot reassign y to something that is not a nat. For example, if you try to reassign a string to y, it wouldn't work because Motoko is a typed language and you need to respect the type of the variable. And this is what we call mutable data. Okay, so let's put our knowledge into practice and try to make something really simple. We try to create our first calculator. So let's start with the configuration file as usual. So we are going to have canisters and only one, which is called calculator. It's of type Motoko, and the main entry point will be main.mo in this folder. So let's make the main.mo. Okay, so let's start with our calculator. We want to store a value and we want to be able to make additions and subtractions to this value. So let's create our actor, and let's make our first variable with the keyword let. So let counter of type nat equals 0 for now. And we want the function to make an addition, and we want the function to make a subtraction. That's pretty simple. So let's start with the function to make an addition. So we want this function to be public because we need to call it from the outside of the canister. It's a function and we will call it add. We want to take n of type nat and we want to return the value of the counter at that moment. So we want to return a value of type nat. And basically we just want to take the counter and reassign the counter to counter plus n. And if you are following carefully, you've noticed that we use the keyword let, and we have an error, expected mutable assignment target. So counter is not mutable, so we cannot use counter here. So we need to change that and use the keyword var, and it should work. Oh yes, and we've forgotten to return the value, so return counter. And this time it's working. And now we want the function to make a subtraction. So public function sub, we take n of type nat, we return a nat again, and this time it's just counter equals counter minus n. And return counter. All right, so let's try to start our replica, use another terminal, and deploy our canister. We want to deploy locally, so just defx deploy. Oh, and actually, let's add a function to query the result of the counter at any time. So public query func show value. We take no argument and we just return the value of the counter like that. All right. So we need to deploy again. All right, our calculator has been deployed locally. Let's try our function. So defx canister call calculator, and we want to add, let's say 10. And it should return 10, okay. And let's try the other function, so sub, and let's sub something like 5, for example, and it should return 5. And we can confirm the value using the query function show value, and it takes no argument. And it's working fine. So let's move on to the modules now. So what are modules? Modules are pieces of code you can reuse in your own programs. You just need to import them and you're ready to use it. So as you can see on the slide, you can add modules to your Motoko code to handle many operations and interact with more complex objects and types, like the array, the list, or the random. And you can see on the picture, so let me show the picture. You can see different modules from the base library. We have the random module, the array module, the list, the stack, the iter, the blob, the nat, the debug. And you have many more, so I will show all the modules from the base library later. And you have basically 3 ways to import modules. You can import modules directly from the Motoko Base Library with the syntax you can see on the picture. So mo base/random, mo base/array. You can import modules from your own code, and I will show you in the video. And you can import modules from external repository using something like Vessel Package Manager. And I will explain what is Vessel and how to use it in a next video. All right, so let me show you the module from the base library. Okay, so I'm on the Definity website in the coding section for developers. And if you look at the documentation, at the bottom of the page, you have the Motoko Base Library documentation. And if you click here, you have all the modules from the base library that are available right now. So you have a lot of them. I will make a video to explain the most common types you can use and the most common functions you need to use. But basically you have array, associated list, blob, boolean, and let's see, for example, boolean. So if you click here, you have the type defined and the most common operation, so the type bool, and you have different functions, so bool to text, bool equal, not equal, compare, and everything. And every time you have the value of the argument and the value of the you have the value of the parameters and the value of what is returned by the function. If you are curious about the base library and how it was written, you can go to the Definity repo /Motoko Base. It's a public repo, and you can check in the source folder. You have the different modules that are used in the base library, and you can see, for example, if you click on array, you can see how the module was written, and you have all the functions that are used in the base library. Let's say we want to upgrade our calculator and add a multiplication function, but we want to do that using the base library. So we are in the nat section of the base library, and we want to use this multiplication function, so this one. This function takes 2 nats, x and y, and it returns the result, which is also of type nat indeed. So let's go back to our code. So if you want to use a function from a module, you need to import the module, of course, and here it's a module from the base library, so it's really easy to import. You just need to import nat like that, mo base nat. And you may wonder, oh, sorry, I made a mistake. And you may wonder, what about this NAT? What about this one and this one? We already use NAT, but we didn't have the module NAT before that. And that's the subtlety of the Motoko language. So you can use the type NAT without importing any module. But if you want to use a function from the NAT module, you need to import the NAT module. And now we can create a new function. So let's say public function multiplication, and we take n of type NAT, and we take m of type NAT, and it returns. No, let's say we just want to multiplicate n to the counter, so just like that, and it returns the value of the counter like that. So we can say that counter is equal to NAT dot, and here you can see that I have all the functions from the NAT module with different explanation, and I want to use the mul one. So I take the counter and I take n, and then I return the counter. All right, never forget that. Now I can deploy again and try my function. So the value of the counter is 0, so I may need to add something first. So let's say I add 5. So the counter is equal to 5, and now I want to multiplicate the counter by 5 again. 25, so everything is working right. All right, so let's try to import a module, but from our own code this time, and not from the base library. So let's create a new file, call it, a new file, allutils.mo. And here you need to define as a module and not as an actor. So like that. And then we want to make a public function. And let's say we want to convert a NAT to a text. So we take n of type NAT and we return some text. Like that. All right, so we need to import NAT from the base library. So this function will be a bit useless, but this is just to show you how you can import from other Motoko files inside the main.mo. So we have t of type text, and we will use NAT to text of n. So we have t, and we return t. All right, this is pretty simple. We use the NAT function from the base library, and we return that. Okay, so this function is public because we want to use it from the main.mo, and this function is not of the return is not of type async. As you can see, there is no async here because we will use this function just inside the canister, so all operation will be synchronous. There will be no asynchronous operation going on. All right, so we have import utils from utils, and let's use this function, and let's say public function to text. We take a NAT and we return some text. And let's say we have t of type text, and t is equals to utils.NAT to text, like that. So we could, of course, we could have directly use this function inside this function, but I think it's better like that to show you how you can use a module. And generally, you will use module when your code base will grow bigger. So that's not the case here, but I think you will need it at some point. And then we can return t. So let's see if this works. And it seems to work. So let's call our calculator, and we want to call like that. We want to call toText with the value, let's say 8. All right, so it's working. The last way you can import modules is from external repository. So you can import modules from using Vessel, and you can import from the Vessel package set or you can import from basically any Motoko repository that exists. And I will show that in the next video, I think. Okay, for the last part of this video, we wanted to talk about upgrades and how to deal with them. So let's say we have our calculator and the value of the counter is 5. Now let's say we want to change the code of the calculator because we want to add a new functionality. At a more basic level, upgrading and changing the code of a canister means changing the WebAssembly module that is running inside. And so now our question is, what will be the next value of the counter? And the answer to this question depends on what we call stable memory. The stable memory of a canister is kept across upgrades. And a stable variable is a variable that is stored inside the stable memory, basically. Currently, the stable memory of a canister is limited to 4 GB, but a proposal recently passed to increase the stable memory to whatever memory is available inside the subnet, so approximately 300 GB for the moment. Okay, so let me show you what is a stable variable and how you can use it. So currently we have this variable counter, and let's try, for example, to call it, so show value, and it's currently equals to 5. We can, for example, use the add function, so add 5 again, and so now the counter is equals to 10. And let's say, for example, we want to remove this function and we want to run dfx deploy. So dfx deploy will upgrade the code of your canister automatically. And now we can check the value of the counter and it should be 0. Yeah, so it's 0 because every time the counter is basically starting again from 0. And let's say we want to keep the counter across different upgrades. And for that, you just need to add the keyword stable, and it will automatically add the counter to the stable memory. So now we can try again, dfx deploy. All right, so let's say we want to show the counter, so it's 0, and we want to add 5. And now we want to, for example, remove this one. So let's deploy again. And now if we query the value of the counter with the show value method, it's equal to 5. So the value of the counter is kept across upgrades. All right, so I've always deployed with dfx deploy, but there is another command. You can use dfx canister install. Let's ask for some help. And when you run dfx canister install, you have the mod flag, so like that, and you can either install, reinstall, or upgrade. So if we run upgrade, it will preserve the value of our stable variable, so the counter will stay to 5 currently. But if we run reinstall, it will reinstall all the code, so you will lose the state of all your variables. So you need to be very careful with the reinstall command. And the install command is just to the first time you run it, it's basically installing. So let's try upgrade, like that. All right, so we need to specify that we want to do that with all our canister. Okay, and now we can query the value, and it's 5. And if we try with mod reinstall, it should be 0. All right, it's reinstalling the code, and now if we use the show value method, it's 0. Yeah, so it's working fine. Before ending this video, I wanted to talk about two special functions, which are the pre-upgrade function and the post-upgrade function, and those are system functionality. So basically, this one runs before the canister is upgraded, and this one runs after. And usually they are used because you cannot make all variables stable. So for example, here we have a NAT, and a NAT can be stable, there is no problem. But if you have more complex objects, sometimes they cannot be stable by default, and you need basically to deconstruct the object in the pre-upgrade method and reconstruct the object in the post-upgrade method. That's a topic for another video because that's more complex than what we did today. But I just wanted to show you that basically we can do whatever we want with the pre-upgrade and post-upgrade methods. So let's say we want the counter to be 10 here, and after the upgrade to be 15. So, all right. So currently the value of the counter is 10, and if I make defix deploy, so the value should be 15 because after the upgrade, it has been upgraded, it has been changed to 15, sorry. All right, it's working, and we can remove that, and let's say we just want the pre-upgrade method. Let's see if it works. And yeah, it's working, it's 10. Thanks for listening to this video. I hope you've learned something today, and if you want, you can share the video on the different internet computer social platforms. Thanks, see you next time.